Welcome to Old Iron Machine Works. I want to take a minute to just thank my new subscribers for taking the time to subscribe to my channel. I appreciate it. This video will be mounting some fluid dampeners onto some 817 Waukesha natural gas engines. These engines normally ran about 1400 RPM, and the customer is going to want to run as high as 1800 RPM while he's pumping water. Here I'm just cutting the slugs out of some 5-inch 4140 material to start whittling away on the adapters. I thought it was interesting that these fluid harmonic dampeners were actually big block Chevrolet dampers that were recommended for us to use. Apparently Waukesha offered their lower RPM crankshafts and higher RPM crankshafts. You want to think that 1800 RPM is considered a high revving engine. It's always nice to have some good chips breaking off, but in situations like this, which happens quite often, it can be pretty dangerous. You don't, even though it's kind of cool to get nice long curl chips, once the chuck grabs it, it sucks it in a fraction of a second. That's when you get in trouble. So what I do here a lot of the times, I really like the Regal LeBlanc lathes because the controls are really nice and easy and sensitive. So here I'm just doing my own chip breaking. I'm actually making two. In one of my earlier videos, I showed where I was doing some flywheel work, putting a PTO on the engine, and it's already went out. But we want to go ahead and put one of the dampeners on the engine that's already out also. So in the video here, you'll see I'm making two of the adapters. I'm very fortunate that the bison chuck on this particular lathe is very accurate, within a couple thousandths, if you want to just clamp something up and check it or flip something over. So once the backside was machined, I was able to just flip it over, crank the jaws in, and just grab the inside hole with the jaws and have it within a couple thousandths. Here I'm just checking the fit in the damper itself. I think I allowed like a thousandths clearance. When mounting one of these up, you want to make sure that you're just clamping it just on the main center flange part of the damper, and that no other place rubs, just slides over the pilot. And when you flip it over, you can clearly see the mounting area, and then if you can give clearance everywhere else, you know, is recommended. This is showing the mounting surface a little bit better in this clip. And here you can see the clearance I left between the adapter and the damper. Here I'm just checking the bolt pattern. It's a 6-bolt flange that goes on it. So just screwed a couple 3/8 bolts in there and just get an overall outside to outside, and then you just subtract the thickness of one of the bolts, and then you got your center to center spacing. Here, using one of the Blake coax indicators for centering up the hole. I really like these indicators, and basically you just work the X and the Y, and you keep moving it until you get very little movement. You know, when you get down to where you get a little wiggle, that's pretty darn close. Here on Super Spacer, I'm just got a little starting bit in it, and I'm just starting at 0 degrees, and every 60 degrees, you know, just taking the starting bit and I'm running it in, and then I'll go in after that with just slightly over 3/8, I think is what I went with, and then I'll finish up after that with a end mill that'll have the clearance built in for an Allen head bolt. Here I just got the drill bit right inside one of the collets. Got all the holes in for the bolts that bolted up to the pulley, and now it's just ready to clamp them up back into the super spacer, dial indicate them in, and then drill and tap the holes for the balancer to bolt to the spacers. Here I just take one of my tap sockets, and just so happens the tap socket for the 3/8 tap is exactly 3/4 of an inch. So I just take a 3/4 collet, clamp it up, and it allows the tap to be able to slide in and out, you know, of the socket with no problems. I guess I should point out the patina on a lot of the tools on the Bridgeport, on the Super Spacer. The shop I work at, the doors are open pretty much all day, even in the wintertime, and it's almost impossible to try to keep moisture off of anything. And when I first started there 19 years ago, it was kind of an ongoing battle. But when you got a steel building and you're opening it up every day, it's really hard to keep stuff looking nice. Here I'm just putting some finishing touches on it. I'll run around with a file and kind of deburr everything, and then I'll go ahead and give them a blast finish, and then they'll go into the vibrator. Now, I agree, this step for what I'm doing right now is totally unnecessary. It's strictly just for cosmetic. Once they're bolted on, you never even see them. These are the nuts that hold the front pulleys on the crankshaft of the engine, and what you're seeing is those things are for cranking the engine over. They got a little crank for cranking for setting valves, and they're too long, so I needed to machine them off to clear the damper. And here we have the finished adapters. Here it's showing it bolted, everything bolted up, and then there'll be a little clip showing the guard around it. Here you can see the degree lines on the damper. They are not used on the Waukesha. All the degree marks are right on the flywheel itself. We also added this clutch, so I had to do a little flywheel work, which I'll show you in a video, and then we upgraded the front seal. This is the original housing where it just had a felt that went inside, and that's pretty much all it was, is just a felt seal. And then I just machined it to put a lip seal in. The way I go about it is I just grab the original inside machine marks, and then I cut the outside, and then I'm able to then go back and then grab the outside with the chucks and then cut the inside. Here I'm cutting the outside of the housing, and the only reason I'm making that cut is just to true it up to the inside hole, so I can grab it now. I can grab that outside with the chuck and go ahead and cut the center, and it's plenty accurate for a lip seal. Now here you can see where now I've grabbed the outside diameter of the housing in order to spin it fairly true to cut the inside. Here I'm just putting a slight little chamfer on just to help the seal go in. Now I'm working on the flywheel end. What I need to do is mount the drive for the PTO clutches onto the flywheel. So I'm just going to get everything, cleaned up, and then head to the glass feed cabinet. I didn't get any footage of actually drilling and tapping and lining up that drive on the flywheel. It was really pretty straightforward. Everything was machined, so I was able to center everything up, drill and tap, and then put a couple dowels just to hold their position. Here I'm making a bushing for the PTO pilot shaft where it goes into the flywheel. They got a couple different bearings. One bearing crazy expensive, but you can get by with using another bearing. You just gotta put a sleeve on it. So this is a case that we are using what we had. So here's the little sleeve that's done. I think I gave it a couple thousandths fit to drive it on, and then the bearing will drive over it. The bearing will be tight on the shaft. Right there, everything's pretty much, you know, a drive-on fit. But with any crankshaft, you want to make sure that you always have in play, so the bearing will actually slide in the flywheel. It will not be tight in the flywheel. If you have a situation where it starts locking up, you know, then you're going to destroy a crank, and that's not a good thing. And when I say destroy a crank, I'm talking about the thrust. All crankshafts have thrust bearings on them and thrust areas. And if you load the crank either too much pressure forward or back, you will have problems and will do damage to it. So this way, the bearing that's mounted to the PTO can always be free inside of the flywheel. Here you can see the dowel pins inside. Once I got everything all centered up, you know, I put a couple bolts in, snugged them up, centered everything up, and then I drilled down and I drove 5/16 dowel pins, one on each side, and that'll just kind of hold its position, and then went ahead and finished drilling and tapping the rest of the holes. Well, this engine's pretty well done and ready to go out. Anyway, I hope you guys like this kind of content. You know, if you do, give me a thumbs up. If you have any suggestions, or I'd love to have any kind of feedback. You know, what you guys think about the videos. As always, I appreciate you taking the time to check out my video.